So here's the problem from 7.6, number 55. It's based on a given equation, which is Newton's law of cooling, which states the following. All right, so if you look at this information, let me talk really quickly about what each of these variables represents. Okay, the T represents the temperature at a specified time, which is the lowercase t, this amount right here. Okay, the TO is the initial temperature. TR is the surrounding temperature. Okay, E is the natural base. R is the cooling rate. Okay, T is the time, okay, and it's in minutes. And then finally, TR we already have. So this is all the information, kind of the legend of what the variables represent. So if we go in and we see what information they provide us. So you're hanging an outdoor thermometer. It's reading drops from the indoor temperature of 75. So that was the initial temperature. Okay, and you move it outside and it drops to 37. So that's the temperature after a given amount of time. It says it drops in 1 minute. So that amount of time, T value, is 1 minute. And it says if the cooling rate is given as 1.37, what's the outdoor temperature going to be? So that means the only variable left, or the only measurement left to even be the variable, is the surrounding temperature, and that should make sense. It's asking you what's the outdoor temperature that surrounds this thermometer so that it adjusts its temperature. Okay, so what we're going to do is we're just going to use the solve feature, plug in all of these pieces of information, and solve for x. So the way that would look, F2 algebra tab, choose solve. Okay, the T value is 37, set that equal to, parentheses, the initial temperature of 75 minus the surrounding temperature, which is unknown, x. All times the natural base, e to the power of negative the cooling rate, 1.37, times t. The t value is just a 1. You don't need to put it there. I just did it to make sure everything is labeled correctly. Then plus the surrounding temperature, which is, again, our unknown. And then we just tell the calculator, comma, x. We want to solve for that variable x. And when we do, we get our answer to be 24.05 is the temperature.